All right, any questions? All right, this should be a recap of where we left off. Unless you're taking notes on your computers, please put them away. All right, so time to stop. As in, what is the time for this car to stop? We know it turns around because initially going negative 40 meters per second, then later going 50 meters per positive 50 meters per second. So since the sign changed, it had to have stopped. What is the velocity when it stops? Yes. Which is going to happen somewhere in here. So we know off the bat that it will stop somewhere between 4 and 5 seconds. And it'll stop closer to 4 seconds than 5 seconds because negative 4 is closer to 0 than 5 is. So this is not as convenient as previous exercises we did where one of them actually ended up being a 0 and it was just very easy to tell what time that was. But this is a trickier one. So we have to go back to the definition of acceleration. What is acceleration? Math. Acceleration.
Velocity over time?
I need better. You're close.
Time, rate of change, or wait.
Looking
Time,
for
rate
the,
of change of velocity.
okay. I'm looking for the formula. But you left 1 or 2 words out.
The time of change of velocity over the time of change of time? I don't know.
You added 2 extra words than you needed. What you just say that again, looking at your notes?
I have velocity over time.
It should not be velocity over time. What should it be?
Change in velocity over change in time?
Yeah, change in velocity, and that is rather critical. It's the change that we care about, not what the velocity is itself. Change in velocity over change in time. The second time you said it, you said time of change.
I was trying to say that.
Okay. And change is final value minus initial value. That's one of the few always. Delta change is always final minus initial. And then time is how much time took place, and that's what we're trying to figure out. That's our unknown. So we're looking at not the final velocity at the end of the problem, but the final velocity when it stops. In other words, 0 minus negative 40. 0 is the final time. My initial velocity is negative 40 over t is equal to my acceleration, which was given to you in the problem. So the math problem we're dealing with, got the double negatives there, which makes it positive, is 40 over t is equal to 9. That's the math problem. Or if you prefer, 40 over t is equal to 9 over 1. That's one of the way your mind is working when you need to use it. So when I have 2 fractions equal to each other, I can cross multiply. In essence, I multiply times the diagonal I know, which is 40, divide by what's left over. So 40 divided by 9, which is 4.5 repeating. Or if you prefer fractions, you can leave it at 40 over 9. But we don't recommend putting it as a mixed number. They're useless for the most part. Units?
Seconds? Seconds?
Yes. It's time. All right, one more piece done. So this is 4.555, however many you want to write. 4.5 repeating seconds. If you need to chop it off somewhere, 4.56 seconds. All right, the delta x without the vector symbol, what is this? Yes. So, displacement has the vector, distance does not. When we're looking for the distance, we do talk about the fact that it turns around. We know one other piece of information. We know it ends up on the positive side of the starting point by 50 meters. So if I just make to the right positive, and I'm going to make this the starting point, this object starts out traveling in the negative direction. After 4.5 repeating seconds, it stops, turns around, and heads back and ends up on the positive side. Not necessarily to scale. I know the distance from the starting point to the very end is 50 meters, because that's what we found right here. We know the time it takes to get from here to here. This was 0 seconds, this is 10 seconds, and this is 4.5 repeating seconds. I need to figure out how far it travels backwards, or sorry, in the negative direction. So how far does it travel in the first 4.5 repeating seconds? Or how would you find it?
Is it distance over time?
Say it again?
Distance over time.
Distance over time?
Yeah.
And what is distance over time?
What do you mean?
Well, I mean, how would I find the distance without knowing? You just say distance over time. Well, I know what the time is, I just don't know the distance.
So you have to like reverse it, like multiply?
With what?
That's as much as I can give you, I don't know.
Okay. Anyone want to pick that up or change it? Jennifer, were you about to ask something or? No? No. Okay. All right, so let's think about this as a separate problem. I have a vehicle that starts out at negative 40 meters per second. It travels uniformly at 9 meters per second until it gets to 0, for 4.5 repeating seconds. Let's accelerate 9 meters per second squared. And I need to figure out how far it travels. It's only traveling in one direction here. If it only travels in one direction, then my displacement and distance have the same magnitude. Well, if I go from negative 40 meters per second to 0 meters per second, what's my average velocity?
Positive 40.
Not positive. Your 20 was right. I said average velocity. If I said average speed, yes. What's the average velocity? Or did it?
Negative 40. I don't know.
Now you have the sign right. The number's off. Did you say 40 last time?
Yeah.
Oh, I misheard. I apologize. No, the average is not 40. Or negative 40. How do you average?
Negative 20.
Thank you. Mia, say it again.
Negative 20.
And throw the units in there for fun.
Meters per second.
There we go. Yeah, the average, when you're finding average velocity, when acceleration is constant, you just have to average the first and the last values. So my average velocity is negative 20 meters per second. Well, on average, average I'm going negative 20 meters per second for 4.5 repeating seconds, how would I figure out how far I would?
You multiply them?
Yeah. So on average I'm going negative 20 meters per second for that amount of time, so my displacement for that first amount of time is going to be negative 20 meters per second times 4.5 repeating seconds. The 4.5 was 40/9. So, yeah, that's not going to work out. It's the repeating thing. Someone could do it, or you'll wait for me to do it in my head. So, negative 20 times, so that's 800 divided by 9, 8/9 is 0.8 repeating. So I'm getting 8, or wait a second, I went too far. I think 88.8 repeating. Anyone? You didn't get that?
No.
What'd you get?
I just did 4.56.
Okay, and what'd you get?
I didn't do it, but I was in.
Oh. Does anyone have an answer, or are we gonna just go with what I did?
I got negative 9.
Oh, yeah, it should be negative. I apologize for that, especially after I hassled you about that. And you had negative 90, you used 4.56?
No, I used 4.5.
4.5?
Yeah. Or should I use 4.5?
4.5, yeah, that's right. It should be something bigger than 90, or magnitude larger than 90.
Negative 91.2.
91.2,
Yeah.
that's using the repeated?
Using 4.56.
Okay. All right. All right, so we have negative 91.2 meters. That's how far it traveled in the negative direction. We've only just solved part of this. So I know that it travels from here to here. That distance is 91.2 meters. That is the distance. The displacement is negative because it goes that way, but the distance traveled is 91.2 meters. So how far does it travel in order to get back to the starting point? Yes. So it has to travel the same distance to get back to the starting point, and then it ends up 50 meters from where it's on the positive side. So how would you find the total distance traveled? Yeah. So 91.2 plus 91.2 plus 50. So I got a 0.4 to 43. So 232.4 meters.
So is negative 91.2, is that the
That's-
distance?
That is, the distance is going to be a positive number. That negative, that is the displacement in the negative direction from start to stop.
Where'd you get negative 20 for,
Here?
yeah.
I'm trying to figure out how far it traveled. It's easiest without more complex formulas to find the average velocity first. And you get that by just averaging, because all we care about is the way it stops moving when it turns around. So you just average the first and last values. That's where the negative 20 comes from. Similar to how we found the average here, except this was for the full 10 seconds. So we averaged negative 40 and 50, which gets you 5. And then the last little bit, average speed. Now we bring in the partial formula that Juan had mentioned. How do you find average speed?
It's distance over time.
That's the one. So you take the 232.4, divide by the 10 seconds, and 23.24 meters per second. Notice that the average speed is different from the average velocity. Questions? I'm going to do one more flavor of this type of equation, of this type problem. There are 6 problems similar to this posted on Blackboard, I think under supplemental additional documents, something like that. With written out solutions and commentary. All right, so I think we've done a couple problems where you know the initial velocity, you know the acceleration, no time. But let's do a variation of that. Let's do initial velocity and the initial velocity, final velocity, and acceleration. So it won't give time. So stick with the car. Our car moves along a straight path. Just a straight line. Initially going negative 30 meters per second. It accelerates uniformly. At 7 meters per second squared until the velocity of the car is 50 meters per second. So I want to find average velocity, time, displacement, time to stop, distance traveled, and average speed. And I might have mentioned this before or said it to a different class, that I would give these, the parts that I'm asking you to find, that is the order in which I would find them. If you can do it without going through that order, if you can do it in a different order than just point arrows to the path that you found this first, then you found that, or however you did it. If you can't figure out time, but if you knew time, you could get the rest of it, then just make up a number for time that makes some legitimate sense, not 0, and not a negative number. Make up a number for time, and then solve the rest of it using that. And most of all, and I will say 110 students have the biggest, on average, have the hardest time with this. Show your work. There are times in which I see 2 different answers that are identical. One person showed work, one person didn't. They're both the same wrong answer. I'm not suspecting cheating. But one person might get 9 out of 10 points, and the other person might get 0 points. Because if it's wrong, and I don't see how you got there, I don't know if it's a Carroll's mistake or what it was. All right, so let's begin. We know 3 things. What are the 3 things that we know? All right, we know that. I thought something else was said.
The average velocity.
Not given in the problem, but we can find it easily enough. But with stuff that's given in the problem, we know final velocity. We know two other things.
Speed? Speed?
We know speed at 2 points, but okay. We still know two other things.
Is it the displacement?
Not given in the problem.
Positive, going straight
Pardon?
line. With the straight line is going positive.
It isn't a straight line. What was the bit about positive? No, you said something about positive. I missed it.
I just said it's going positive.
It is a straight line. There is a positive side and there's a negative side. Or positive direction, negative direction.
It ends on the positive.
Pardon?
It ends on the positive side.
Yes, it does end on the positive. How do you know?
Because it was going
15.
Good. I see people pointing and saying partial words. Let me get closer. Don't get quieter just because I'm closer.
To be honest, you said it.
Because it started off at initially going negative 30 miles, and then it ended up at 50 miles per second.
So why does it mean it's going to end up on the positive side?
Because it's moving in a positive direction.
I can still move in the positive direction, be on the negative side.
We're past zero. So past the starting point?
How do you know it passes the starting point? First off, it does pass the starting point. It does end up on the positive side, but how do you know?
Because the 50 is positive. You know you pass a zero.
So, no, that's not true. Because if I ended at 20 meters per second, it would have ended up on the negative side. Although it would be going in the positive direction at that moment. It's like you see the ballpark, but afraid to get into it.